Pause your video and solve the brain starter. All you have to do for this one is you bring the exponent out as a coefficient, so you get 27x, and then you lower the exponent to the 26th power. And that is the derivative of f of x. Today we're going to look at some basic rules of derivatives. If you have a constant function, like say if f of x equals 6, one way you can think about handling this thing is if you put a pretend x variable there, like x to the 0, which is just 1. So in this case we would apply the same power rule, where we'd have 0 times the 6, which is 0, and then x to the negative 1, I suppose. But essentially what happens is 0. So anytime the original function is a constant, that means the derivative is just going to be 0. Now, we hinted at this next property real briefly in the last one, but let's look at it again. If there is a constant term out front, and you want to bring down this exponent, really all you end up doing is just multiplying this times the exponent. So, for example, if we had something like f of x equals 5x squared, we bring the 2 out. 2 times the 5 gives you 10, and then x. So 10x would be the derivative. And this one's fairly intuitive. If you have a sum or a difference, you can just add these together. So like, if this is g of x plus h of x, then the derivative is the derivative of g plus the derivative of h. So if you wanted to string things together, like if f of x equals x cubed plus 2x squared, you would first do the derivative of x cubed, which is 3x squared, and then you would do the derivative of 2x squared, which is just 4x, and that's your derivative. So let's get the derivative of these functions. This first one is going to be 15, because you do the 3 times 5, x, and then drop the power, squared. And this 4, since it's a constant, just goes to 0, so your derivative is 15x squared. Now, the easiest way to handle this g of x for now is to first distribute this x to the 5th. So, we'll end up with 2x to the 8th plus 4x to the 5th. And that's just g of x. So to take the derivative of g of x, it would be 16x to the 7th, because we do the 8 times the 2 and then drop it 1, plus 20x to the 4th. And there's your derivative. This one, we're going to divide everything by an x term. So, the first thing I want to do, I'm going to rewrite this the square root of x to the 5th term, and I'm just going to treat that as x to the 5 over 2. So here, essentially we're just going to drop each one of these down a power. So our new h of x is going to be 5x squared minus 12 plus 6x, and then we subtract 5 over 2 minus 1 is 3 over 2. And now we can take this derivative easily. This first part goes to 10x. The negative 12 goes to 0 because it's a constant number. And then we're going to do 3 halves times 6, which is going to be 9. And then x to the subtract 1, 1 half. Which, of course, you can rewrite as 10x plus 9 square root of x.